Okay, so yesterday we discussed about the mutually exclusive events and not mutually exclusive events. So today, let's have another lesson. By the way, before our next lesson, any questions about mutually exclusive and not mutually exclusive events? None. Okay, that's it means that you have understood the lesson very well. Do you? Yes. Good. Okay, so this afternoon, let's have dependent and independent events. This is still under compound events, probability of compound events. So, this afternoon, we have the following objectives. Number one, you will be able to find the outcomes of an experiment. Number two, you will be able to find the probability of A and B using the multiplication rule. And number three, apply real-life situations that involves dependent and independent events. Okay, so we have three objectives for today. Okay, how do we find the probability of dependent and independent events? What do you think? How do you find the probability of dependent and independent events? Let's try to find out. Let's try to check. Okay.
An independent event doesn't change whether or not you're going to choose something else or choosing something in a related event when you're trying to find the total probability. When we're choosing mutually exclusive events, when we're figuring out the total events, we take the probability of one event and add it to the probability of the other. When we're dealing with independent events, what we do is we take the probability of one event, say the probability of A, and we multiply it by the probability of B. So the probability of A and B, assuming they're not mutually exclusive, is probability of A, or the probability of the first event, multiplied by the probability of the second event. So what we're talking about usually when we're talking about a probability, we're talking about something smaller than 100%, right? We're talking about effectively a fraction. So when we multiply these together, we get something even smaller, right? If we have a fraction multiplied by a fraction, we get a smaller fraction because we only have a portion of a portion. And that's what you should expect to find. If you have a certain chance of doing something, then your chances of doing it and something else that's also unlikely are even less than they are of doing just one or the other. Let's do an example. Let's say we're talking about lunch. Everybody likes to talk about lunch, right? Say for lunch, there are two sets of possibilities. For your drink, you can either get milk, or juice, or soda, or water. And then let's say for your meal, your food, you can get a burger, or a sandwich, or chicken, or pasta. So your chances of picking any one of these four choices for drinks, so the probability of any particular drink is 1 out of 4, or 0.25, or 25%, depending on how you want to think about it. Your chances of picking any one of these four foods to eat are going to be the same. And notice how we're still kind of separating them. Oops. There we go. Now we have to go. Your chances of picking any one of these four foods to eat are exactly the same. So the probability of your food is also going to be 1 out of 4, or 0.25. Now, the chances of picking any one drink, say milk, and also any one sandwich, are going to be whatever the probability of the drink is, so the probability of the drink, multiplied by the probability of the food. So if we want to know what the probability of milk and probability of sandwich would be, then we need to take the probability of the milk, which is 0.25, and multiply it by the probability of the sandwich, which is also 0.25, which would actually probably be easier to do in fraction form because we just multiply straight across, right? So we have 1/4 times 1/4, or 1/16 chance of being able to get, of picking milk and sandwich. So we take the probability of the first thing, and we multiply it by the probability of the second thing to get the probability of the two of them together. And we can see that the chances of getting them both at the same time are significantly less than the chances of getting either one or the other. Because there's obviously a lot more options. If all I'm saying is I have to get a sandwich, there's 4 different ways I could get a sandwich. I could get a sandwich with milk or juice or soda or water, right? But there's only one way I can get a sandwich with milk. So that combined probability is significantly less than the probability of either one of the two choices on their own.
Okay, so in the video, what have you noticed with the presentation of the sample space or the outcomes? If you have 4 lunch drinks and 4 food. There are 4 drinks and 4 food. How many sample space are there? How many sample space? Let's have Obate. Lilian.
Sample space?
Yes. If you have 4 choices of drinks and 4 choices of food, how many sample space are there?
16.
Okay, so you have, in the counting technique, you have, if you have 4 choices of food and 4 choices of drinks, there are 16 choices all in all. Combination of 16 choices all in all. You have 4 times 4. Okay. So in the independent event, if you are going to get the probability of getting 1 out of 4 drinks, so you have 1/4 chance, and getting another probability of B is getting 1 out of 4 food, so you have another 1/4 chance. So multiply it, the probability of A and B, therefore you have 1/16. Okay, so that's independent events. So 2 events are independent when? When can you say the 2 events are independent? Anas, yes.
2 events are independent because the outcome of the first event does not affect the outcome of the second.
Okay, very good. If the event A or the first event does not affect the second event, it is independent event. Okay, so this is the formula for independent event. And what have you noticed here? You have the word, usually and. If you have the word or, it is mutually exclusive events. Then you are going to add last. If you have the word and, it's independent event. So it implies that you are going to multiply. So you have probability of A and B is equal to probability of A times probability of B. Also known as probability of A. What is the symbol? Okay, intersection B is equal to probability of A times the probability of B. Okay, questions? Clarification? Let's have one example. Kindly read the example 1. Yes.
Example 1. A coin is tossed and a six-sided die is rolled. Find the probability of landing on the left side of the coin and rolling a 3 on the die.
Okay, very good. Thank you. What is the first event? Equal. Okay, the first event is tossing the coin. Okay, and landing on the head side. Very good. How about the second event? Just landing.
The second event is rolling a 3 on the die.
Okay, rolling a number 3 on a die. Are the 2 events dependent or independent?
Independent.
Okay, why independent? Let's have Teves. Why independent?
Because when the coin is tossed, it will not affect what will
come out when the dice. Okay, very good. Yes, when you're going to toss the coin, it does not affect the dice. Does it affect? No. Okay, it does not affect the dice. Therefore, it is independent event. Okay, so we have here, first event, we have the probability of 1/2. The second event, probability of 1/6. 1/2 times 1/6, that is equal to 1/12. Okay, last one example. A card is 2 cards. It is then replaced and the second card is chosen. What is the probability of choosing a jack and an 8? What is the first event? Okay, we have, very good. Choosing a jack is the first event. Second event, Ryan. Okay, choosing a number 8. Does it affect the other? Okay, it does not affect. Jack and 8 does not affect one another. Event A does not affect event B. Therefore, this is an example of independent event. Okay, so we have the first probability is 4/52 because how many jack are there in a 52 deck of cards? 4. Then how many number 8? 4. So therefore, you have 4/52 times 4/52. That is equal to, okay, 1/169. Very good, Rian. 1/169. Very bright. Okay, so let's have a short activity. I will divide you into 5 groups. Okay, so in this activity, you are going to write one event that shows independent event. One event. You write one event that shows, or one experiment that shows an independent event, and then you find the probability. After 5 minutes, your answer must be posted on the board. The first one to post will gain 5, will earn 5 points. Independent event. Yes. Write one experiment or event that shows an independent event and you find the probability. The first group to post their answers will be given 5 points. Okay, let's have the first group.